Now with user-defined types, we'll cover structs, enums, static const, and type aliases. Along with an exercise, the struct person here, Rust allows standard struct syntax, no type def required, no inheritance allowed among structs, few specific types of structs like zero-size structs to implement a trait. Now let's implement a sample. We'll define a simple struct called person. We'll give it a first name of string, last name string, a gender with char, and age with u8. Now this describe function will get passed a struct reference, and it'll simply print out a descriptive string for that. So it'll be like first name, last name is ages years old with the gender of it. So here what we'll do is, for gender we'll match the person gender and allot it a matching string. So M to male, F to female, and if anything else pass, then we'll give non-mrf. Now let's create our main function. Let's allot John Doe as a person to JDoe. F name string from John. Let's copy it. I'll name Doe. Gender M for this, and age 100. Now when we describe it, it should print a descriptive message. Before that, let's get it out and pass them nicely to println. Last remaining is gender. Let's pass that as well. Now let's try run it. John Doe is a 100 years old male. Now let's make it mutable. Let's play around with structs a bit. So we can simply access the inner fields using dot notation. Mutate it. Let's create a variable with the field name itself. So F name is Jack, and age, one of the other fields, is 55. So now what we can do is we can create a struct called for Jack by simply passing the F name and age variable names. For the other fields we'll have to pass the values to, but for F name and age, since those are the field names itself, it should understand by itself. Let's check now. Seems to work fine. Let's get back and try a few more things. So the syntax .every, as it's mentioned here, lets us simply fetch fields from another struct of the same type. So if we say a Jane person, since the first name is Jane and gender is F, everything else, if borrowed from Jack, it'll have the same age and last name. So let's try it out. Same age and last name. Let's move on to tuple struct. It's used when field order is sufficient, like XY in a point. Accessed with dot index notation, commonly used as a single field wrapper to enforce a familiar type name. So let's try a sample for this as well. Struct point 3D. Let's try out a new one, variation of the point that was in the sample. So what we'll do is we'll try assign it point for cube. So each point would be a 3D point that would itself make this cube that we see. We'll simply assign it XYZs for all the 8 points that it requires. Now that it's done, Let's simply print it. We'll do a debug print. We'll need a rewrite debug notation above it for that. Let's try run it now. Let's try print the inner point data as well. That can be accessed using dot index notation for a tuple. As you see, it's working. Let's do a pretty print. The output seems fine. As you already mentioned, the new types are a great way to encode additional information about value, a phone number, odd number. So let's try an email type here. Bit variety of what example we saw there, and we'll create a simple struct with email in it and just assume other details are part of it. So let's write a function called sendMail, and an email is passed to it, so only an email would work. Although email has a string, if a simple string gets passed to it, that shouldn't. So we are kind of forcing a type specific functionality of sorts. So let's create an account here for Jack. We only need to assign email since other fields are not part of it yet. And then when we try to send mail to it, let's finish with it. Account.email once passed and run. So after cleaning, as you see, it's working with when email is passed to it, but if we directly try to pass the string to it, it should cause an error, as it's expecting an email type here. So it's not the same as typedef, but kind of wraps around the type that we want and can be used in that fashion. Traditionally, enums for variants of same kind to be assigned different values. So let's try the sample code now. We'll add the derived debug to help us in println. So CPU, GPU here are the same variants on the compute device. Let's create a request handler. So what we are trying to do is we are trying to primarily create a flow where we pass it a request and it pass it on to where to run or add to queue. So error is a simple variant here. Run is a tuple variant where like it will need to be passed what compute device, CPU, GPU need to run on. And add to queue is a struct variant, so it can be like supports different types of variants as part of it. Now let's define the struct request also that we are using it as add to request under request handler. For now we'll just add prompt and model. So let's define the main function now. We'll start with the request handler and assign it a compute device of CPU. Let's print it, so we'll see the kind of notation it gets. Let's make it mutable. We'll change it to GPU. Check on that. So we'll keep on trying different varieties of it. Let's try for these for now. the tuple and the symbol variations. Now let's go ahead and try for the struct variant as well. So add to queue. The queue type was a string width, so a string from to begin server, and request was a struct in itself. So prompt and model, so string from whatever, and the model with GPT-2. So this kind of enriches the kind of variants it can have. Now let's see how the print for this comes out. REST applies optimizations where it can to make enums use less space. More details can be explored on some none types. So let's try the sample code here for now. Use smallest size int if the allowed variant doesn't cover all bit patterns, invalids are used, and discriminants can be altered by assigning a value, as you see here. Statics are not inlined. Significant when memory addresses of priority always have single address. All mutable access are unsafe, unlike immutable statics. Accessible from any thread alive during whole program exec. Let's try a sample code now. So primary use cases for these are generally global locks, atomic counters, or when interfering with C legacy. But we'll see a simple static blah here. That was it. For const, eval at compile time and value inlined at all usage. Only const functions can be called to generate const values. Const functions are runtime callable. If static isn't required, then this might be safer. So let's do a sample code. Again, for this, we'll just do a max len, and in main, what we'll do is we'll simply provide a random text for now, but the main logic is here where based on the char's length of a string, it will primarily send if it's of max length or not. Again, this could have been done without a const variable, but it's primarily used for occurrences where that value is not to be changed overall, and since it's inlined, it's much more efficient. Type-Alias can create a simpler name for another type to be used, commonly used for complex long names like these. So let's go ahead and do sample code for this now. These are also used to have a more significant name to represent context in code. So that's what we'll be doing here. We have defined a struct num with a whole and a decimal part, and we'll do type aliases with money and kilometers. So both have different contexts in code, so that will help us in presenting it and writing the code with context much more easily. So with display money, the money alias is passed. It still has the dot whole and dot decimal parts, and with kilometers, display distance, can use it again, the dot whole and dot decimal parts in a different context altogether. Now we'll simply see the usage of these in main. So we'll assign money to M. Let's say 2.74. And kilometers to K with 9.14. And we can do, let's do a format here and return the string back. So format does a simple effect as of println, but instead of pushing it to std out, it simply returns a string. So display money and display distance would give us a correct representation for the context that we need here. So that was that. Now let's move on to our next section, the elevator events. So this is a simple exercise here that will create a data structure to represent an event in the elevator for a car. It has simple events being called in main. Let's copy it first, move it into our elevator.rs and have a quick look into what all it's doing. It has an event enum, a direction enum, several functions for where the events are passed, and then those functions are being called in main, like car arrived, car floor button pressed, lobby call button pressed. So these functions seem to be the main bits that define what all events should be there. So let's do a grep of functions that are being there other than main, which are returning an event, so we can understand what all events we need. Let's copy them, paste them here and clean them a bit so we can define our events clearly. This seems to be a tuple event. This is a simple variant. So car arrived, car door opened, car door closed, then lobby call button pressed and car floor button pressed are all button pressed events with a floor bit associated to it. So let's create a button pressed bit and we'll move it here so we can easily manage it here. So what button gets pressed will be managed in the enum button, and we can have a type floor with I32 since it's being passed as such. So we can have primarily in button, we can primarily have lobby call button pressed tuple variant with floor, and we already have a direction enum, so we don't need to create for that. Let's clean up the names for this. So button pressed part is common, we'll remove that. So lobby call and car floor seems reasonable. Going below, direction up down. Okay, let's copy these up here. So we'll return required event enums. Car door closed, car arrived. Since you already have the floor values and direction values passed here, we don't need like extra editing to be done for that. We'll need to have a button enum passed to this event bit. So let's clear this out. For lobby call button press, we'll send lobby call with floor and dir, and for car floor button press, we'll send car floor with just floor. Seems to be done. Yep. So let's save it and try running it. Seems you're good. Ground floor, lobby call 0 up. Car arrived, says car arrived. A car door opened, calls car door opened enum. Let's see what solution we have here. Yep, it seems similar, just that the ordering of our type floor and button is a bit below in this sample that's online. Yep, good. Next for day 2.